laptop to this computer so that I can share. Okay. Can you see my screen?
Yes, sir.
Okay. So today's class on soil parameters, and there will be one assignment or say assignment. Yes, assignment on this one, and you have to submit it maybe next week or next week, depending on Umama's time. Abu Umama. Okay. So this is the soil parameters. Now, soil parameters we know. Parameters are very important, you know. Soil parameter is very important. Depending on that, we have to design the foundation. So if the foundation is not good enough to take the load, then what will happen during earthquake? It may fail, it may fail. So if foundation failure is a catastrophic failure, in fact, if there is any failure in foundation, the whole structure will be affected. Okay, that's why it should be designed very carefully. Very carefully. The most important part of the building. If the foundation is good, then there'll be maybe there'll be some cracks in the building, but you can repair that one. But if foundation fails, then it will be damaged. The building will be damaged. During earthquake, especially during earthquake. Okay. So here we have, you see, the parameters we know. Oh, what's that? Okay. Uh, 10. So we have cohesion. Okay, cohesion. Cohesion mainly for clay type soil, cohesive soil. Cohesive. Cohesive soil. We have cohesion. Clay, even say clay sand, it will have cohesion. Clay sand, even silty sand, silt has some cohesions even. Okay, cohesive silt we know. So cohesion. The angle of internal friction. So this parameter, these two parameters are actually very important for any design. In foundation engineering, we saw the foundation design was done with these two parameters. Then fine content. What is the fine content? That is, I mean, not 200C. I'm not sorry. Yes, 200C more than 50% pass through. That is clay type soil, and then if retained, then it is sand type soil. The fine content we need it. We need the fine content. We need Young's modulus. Young's modulus of the soil. I mean, to calculate the displacement settlement. Settlement. So we have relative density. Depending on the relative density, there are some parameters, and depending on these values, so we may need to calculate this or relative density. Then over constant ratio, that is mainly for clay type soil or cohesive soil. We know this. Then GS, specific gravity of soil. These are basic parameters. These two basic parameters always we need to determine from the soil test, the field test. And other parameters we have to calculate even. Then from level test, what we get? From level test, we get this that is for consolidation test. Consolidation, say that is body ratio. This is sigma dash, sigma dash is log scale. Log scale. So the equation is this, not equation. I mean the curve is like this. Curve is like this. If so, this is NCL line. NCL line. So this is the, if you remember this CC, and this we consider this is straight, this is CS. So this from consolidation test we get this parameters. Compression index, well index for getting the uh, displacement, calculating the settlement or displacement of clay type soil. Then liquid limit, plasticity index. These are we get it from the laboratory. This is from consolidation test or orbital test, you can say. Then from field also we get it VS, we can get shear wave velocity. Okay, some values. Then K, subgrid reaction. Then K naught, lateral earth pressure coefficient, we know. So these parameters we can get even from the field. Okay, from field. Then question that did you see my soil test report? Did you go? Okay, have you gone through that one? So please check it. Gone through that. I mean, soil test report. Only one page are there, maybe 2 pages maximum. So here you will see in your this year the supplied soil test report does not have any I mean test, any I mean laboratory test. All are only field test. That is SPD, standard penetration test. So from SPD, we get what? An SPDN value. So at SPDN value. So this N value will use for calculating the parameters. And soil type. There also soil type is written CL, ML, SN, and so on. Okay. I mean, in your soil test report, you will see this one. So I can okay, see here. That one. Whether I gave you some, say group one here. So what you have? So it has boring depth 30 meter. So it has boring depth 30 meter. So that is SPDN value is there. SPDN value type size. So it is SM. SM. It is CL, SM, CL, ML, CM, and so on. So these things, SM or CL, it depends on the grain size and that LL, liquid lipid plastic limit, PL, plasticity index from that place, from that one. Okay. So you see the values are here. This 6, 7, 2, 19, 6. So only SPD value. If we only here is okay, no other, I mean, parameters are there. So with depth, you have only the SPDN value and then soil type. Okay. Now come to the parameters. Okay. Oh no, not this. Parameters is here. Okay. So this N value, usually we use N 60. Yeah? Uh-huh. Right. So use pen. Okay. So N means this N, and N 60% energy release. So in your say in your report that I supplied, I mean 10 reports. So in your report, I have N value only and consider this is N60. Okay, all please consider this N60. Okay, the value is the field test is N60. Most of the cases in our country, they use the I mean SPT I mean hammer, that is N60. Energy release is N60, 60% energy release. So this is, you see the question for what? For all clays by Terzaghi. All clays by Terzaghi. So you see, for clays with high plasticity. So Terzaghi, I mean, gave this equation C equal to 0.066 N. So 0.06 is N TSF. So TSF means ton per square feet. Okay. So we need in kilopascal. So I mean, you calculate with this one and then multiply with 95.76 to get the unit of kPa. Okay. So here, what you have to use? So we'll use mainly this Schwarz equation. Okay, not Terzaghi's equation. We use Schwarz equation. Okay. Medium plasticity. You can check your LL is not given. Though LL is not given, so you can see whether this is CH. CH is this. MH is this. Okay, MH. MH means high plastic silt. CH means high plastic clay. So for this one, the equation that you will use is 0.13 NTSF. Okay, so forget about the medium plasticity. এটা আমরা ভুলে যাই. Okay, so it's low plasticity, CL, CL, because you don't have a LL or other things. So you use these two equations. Schwarz equation, please write it, use it, use this equation and this equation. This is for CH, this is for CL. This is low plastic layer. For ML is different. ML is silky. Huh? So ML will not come here, but MH will come here. MH. Huh? So CH and MH. If there is anything there in your report, MH and CH, then you have to use this equation 0.13 NTSF. But you have to multiply it by 95.76 kPa. For low plasticity, so use this. Okay, C equal to 0.038 NTSF. Okay. So this is the things that you have to use for cohesive soil, mainly clay soil. Then angular internal friction, as only SPD n value is given. So angular internal friction will not use this, but for road design, because it was first proposed by Shahin for road design, especially 0.3 and 27, phi equal to. Okay, and you see it was proposed in 82. And then Peck, Hanson, and Thornburn, they copied. No, I mean this one. He copied this one, in fact. And the Peck, Hanson, and Thornburn proposed a graphical form. One graphical form. They are from MIT, MIT Machines Technology, Professor Peck, Hanson, and so on. So in our, FYDP, we'll use this equation. Okay, for silt and sand, for ML, SM, SP, and so on. Okay, whatever the cases or stand is there or silt, still is there. So this is 0.3 and 0.005 and n square plus 27. Okay, so maximum n value, whatever it is, it gives you the maximum n value will use 35 because we don't have 30 degree. So 5, maximum, because we don't have FM very high. In so USA, the soil, the sand, their grain size is bigger one than our case. Our case is very fine. Coarse, we don't have coarse, rare coarse. Sillet sand. If you use sillet sand, then you can even go for 38. Okay, 38. So if say you get n value is equal to say 15. Now 15, 30, say 30, say 30. So 30, so what will be the phi? Phi will be 30 into 0.3, what is 9, 9. Okay, plus 27.1. This is almost 0.1 or 2, I don't know how much. So if you calculate, this one is 36.1. And even with this one, maybe if it is 36. So it is 30, say 36, I don't know how much. You can calculate. 36. So what you write there, you write 35 degree. Maximum 35 degrees. Say you have 50. N value 50. Many places you will see N value 50. 50. So it is 15 plus 27 here. So it is 42. So more than 42. What's that? Oh, okay. Again. So 42. So you have to use 35. Okay. 35. Understood? So what we use here, two equations, just again I am telling, I am repeating this one. So here for clay soil, use this one for CHMH, this one for Cl, and this one, I mean this equation for Ml, Sm, Sp, sandy soil, silty soil, and so on. And non-plastic silt. Okay, this page is very important for you, and because you have to use these equations for calculating C and phi, and that C and phi will be used for foundation design in Plaxis, in hand calculation both. Okay, then relative density. So relative density, the equation proposed by Ishihara and his student. Okay, Professor Ishihara actually he was with us in Prof.Dr also as an paper expert. Okay, so, he knows me and I know him very well. I mean from Japan. Is very good. I mean, in geotechnical engineering, also earthquake engineering. I mean, the first, I mean, book he wrote. The first book of earthquake engineering was written by Professor Ishihara. He was expert in earthquake. Okay, so here N160. Okay, N160. You see N60. N60 means N that I said. Okay, N60 means N. And N160 somewhere we have to use somewhere here. I mean, later we'll see. If you go, I mean, downward direction, then you see N160. So N160, that is the equation Cn N60. So N60 is N field 1, then Cn, this is multiplication, some multiplication factor. Okay. So this one is the equation of Cn. So this equation use. So you need, what you need? You need the initial stress. I mean, initial stress means in situ stress, vertical stress, sigma 0 dash, effective stress. Multiplied with this one, then you will get Cn, and then multiply this, you will get N160. Okay. You see sigma V0 and sigma 0 the same. Okay. PA is কত বলো তো PA 98.1 PA. Use this one. Then D50, you need this D50. Okay. But as I did not give you, I did not give you that grain size analysis, then you cannot get the D50, because you need the grain size analysis. Then you can get the D50, 50%, 50% finer, 50% finer. Then this is D. But as you don't have any, but you need it. You need it for environmental design. And okay, if I check, if I can give you maybe. I mean, environmental জন্য লাগতে পারে, বুঝছো? Okay. So you need D50, then you need sigma V0, and then N60. And then Young's modulus of soil, according to H2 code, according to 14. So for here, I mean here, you use these equations. You use these equations, I mean, mainly for clay type soil and silt. For silty sand means SL. SL. You use this equation. Okay. SM, you use this equation 300 into, so what is the unit of this one? KPa. And this one is KSF. Okay, so one KSF is KP. You have to convert it. So don't mix each other. Mix corona again. So you use this equation. Okay, this is also, I mean, in H2 to 2040 in terms of KPa. So 300 into N160. So how to calculate the N160? We can get it from here. Okay. Then clay sand. If it is clay sand is this. Clay sand. You should see whether it's written clay sand in your report. It's written. Okay, it's written. Clay sand or not. Then gravity sand. I think no gravity sand are there. But if it is, then you have to use this equation for This one and then 4 greater than 15 and 60 greater than 50. There are two equations. And over consolidated cell, you don't know whether it is over consolidated or not. So it's better we will not use it. We use only this SM, I mean this equation and this equation, clay sand and then silty sand, this equation. And for gravelly soil and gravelly sand, you have to use these two equations. But I think you don't have this type of soil. So this is also H2 for clay type soil. For clay type soil, it is for H2. So clay, if you see, sensitive, medium stiff, stiff. Okay. And then uh, sand you don't need, only for these three, only these three. So use here, if it is in soft clay, if it is in soft clay, use this 100 TSF, but you have to convert it. TSF, it is TSF, somewhere it is KSF. TSF is 95, not point something. So multiply this, then you will get the KPA. The medium stiff to stiff clay, 350, and then very stiff clay, 800 TSF. Okay, use this. It is written, use in your soil report. And soil report is written stiff clay or medium stiff clay. So we can see whether it is written or not. Okay, you see here written medium soft to medium stiff clay. What you will use? Okay, medium stiff. Soft to medium. So medium stiff, you have to use this. So medium stiff, it is medium stiff. Then okay, here also medium stiff. You see, medium stiff. Okay, medium stiff. Okay. Then uh, okay, this is medium, very stiff, very stiff. So you have to use the stiff one, stiff. Okay, medium dense and so on. Okay. So in this way you can select the parameter, I mean equation from your, uh, I mean from your, soil test, soil test report. Okay. So this one, medium stiff to stiff, then very stiff, use this. And very soft clay, you have to use this 100 only. Then subgrade reaction for granular soil. Okay, is also in BNBC code that I showed in sometimes. Sorry, BM dash book. Okay, also BNBC code. So IS Indian standard, like Indian code. So here, always you consider your water table at the top. So it is somewhere it is given, not at the top. If we come to the previous one, so you see here the water table. Is there anything written? Nothing written. Now water table is borehole depth. No, nothing is written. Sometimes it is in somewhere here like this. But always consider water table is that at the top, because our ground level is almost 7.5 and so on. So it is less than 7.5 RL, in sea level. So in the Dhaka city, the highest flood level is 7.5 RL, 7.5, plus 7.5 meter. So it is 4.6, means underwater it is, it's underwater. So whatever the soil water table in your report, if it is given there, so don't use that one. Use water table at the top. Okay, water table at the top of the ground. Okay, from the top. Okay. Now, as it is submerged, the water table is the top. It means submerged condition. So what you use for very loose sand, for sandy soil, very loose sand use less than 40, less than 40. Okay. So what you'll use say 200, less than 200, use say 200. Okay. If it is uh, okay, I mean it is say 2 or something, even less up to 3, I mean 3, and 0 to 4. Okay, 0 to sorry, up to 4. Okay, up to 4 it is. Then 4 to 5, 4 to 10. 4 to 10, use the average of this. Average. Okay, average of this. Or you can interpolate. Which one is better? I don't know, but interpolation is good, I think. Interpolation is good. Okay, what you do, just, I mean, please remember this one. Do interpolation. Say SPT and value, SPT and value is 4. So the value is submerged coefficient NH equal to NH is 200. Okay. And then for 10, SPT and value 10, it is how much? 1400. Okay. So do the interpolation here. Say you have parameter that is 8. Say you have, say, I mean, and SPT and value 8. Okay. Average SPT and value 8. Okay. So you will get the value from here. Okay. One thing maybe I forgot to tell you before. So you divide your, I mean, soil according to this one. Okay, according to this 0 to 4, 4 to 10, 10 to 35, and more than 35. 4 division for sandy soil. Okay, for clay soil, clay type soil, not here, but there are another table. Table, I don't know whether I gave it or not. No. Okay. So that is 0 to 3, like this, 0 to 4, this one, less than 4. Stopped. Maybe this is 10, almost same, in fact, almost same. It is more than 10 or so. Okay, I have to check it and I will let you know. So again, come to uh, the here. So now you see, uh, here he gave is good because it's given. I mean here, 7, 2. Only, I mean, 2 parameters are here for clay CL. Okay, SPTN value 7 and SPTN value 2. So what you will do, you divide your, I mean, soil layer, soil profile. This one, this, then this is siltation and this, because it has many, so you can divide in this way. The same as your, I mean, report. So you make this average. So here SPT value will be how much? Average SPT value will be 3.5, 3.5. So here only one, say 19, here only 1, 5. So here ml, so it is 9 plus 7 divided 2 is 8, 8. So only 6. Now coming here, okay, again here you have 4 values or 3 values, 1, 2, 3, 3. So make it average, okay, average value. Then here you have to divide it because you see up to this, up to say 22 meter, up to 22 meter or 21.5 meter, it is this one. So make it average with these 3 because it is out of, I mean, out of range. Okay, 23. So this is only one layer you have. Only another division you can get. SPTL value 23. Then make it average for this one, 48 and 26, and this 50. 50 and 15. What's that? Does it mean? 50 and 15. Here 15 mean this 15. This 15 means only you get okay, 50 blows you got it for 15 millimeter, I mean settlement, huh? Okay, and 12 millimeter settlement like this 50. So this 50 use SPD is 50 in fact, huh? Okay. So coming here, so in this way, the average SPD you will use here, huh? SPD, then you will get the values. Then subgrade modulus will be, that is NH, then subgrade modulus will be Z into NH. Say you layer. So this is the things here. So subgrade modulus, huh? Subgrade modulus, say for this layer you are considering. And the center of this is the SM, huh? The center of this is say 10 meter, huh? 10 meter. So you got an NH, sorry, NH, yes. Say you got NH is say 1500, say, huh? 1500. So the K, the subject modulus, K. KZ is written, but it is K. K equal to NH into 10. So it will, sorry, 10. So it will be 1500 kPa. Okay. Sorry, kilonewton per meter cube. Sorry, kPa, kPa. It is NH. Huh? NH is kilonewton per meter cube, but K will be kPa as you are multiplying with depth. Understood? Okay. Then for cohesive soil, you have to use this one, but this value is very low. So what we do, we use it in fact this in practical case is the ES divided by 1 minus Poisson's ratio. Okay. So what is the Poisson's ratio for your case? So Poisson's ratio you is from here. Okay, Poisson's ratio. Use these parameters. The graph. Poisson's ratio for sandy soil use point 0.4. Sorry, clay soil use 0.4. Okay. Then for silt, use 0.3. 0.3 for silt. 0.35 up to 35 is given, but you use silt 0.35. Yeah, 3 is okay. Up to 3, but use 3. 3. Then sand, sand use 0.25. Okay, 0.25. For all sand, loose, medium, and whatever it is, use 0.25. Okay. And gravel, you don't have gravel. If it is gravel, then also use 0.25. Okay. So 0.25 for this all soil and 0.3 for silt, 0.40 for clay. Okay, understood? Because you need this Poisson's ratio. And you already know how to calculate this E, so you can get, the subgrade reaction of cohesive soil. Okay, then another parameter you have to calculate that is for mainly, earthquake, Gmax, shear for shear. Gmax is the rho V Gs square. Rho Vs square, we need this. So this is the this equation usually we use. Okay. So there is another equation recently proposed by the consultant, some professors of Turkey. They proposed one equation. Considering more than 1,000 data in our country, not in a country, in Dhaka metropolitan. The studies was done by World Bank under Raju. Raju. So they proposed one equation for our soil. Okay, previously we did not have any equation. We used the Japanese one, Kota and Goto. They proposed in 1978 this equation, and it's widely used all over the world. 79, and still we're using, because that new equation that was proposed by the team, it was no, it is not published. it is published, and as it's not published, it is not in the BNBC code. That's why we will use only this one. 69 n to the power 0.19 d. What is the d? D is the I mean depth, as I said. Where is your center point? That depth. Then n is that n value. Then f1 for clay type soil is 1, and then sorry, f1 is I mean the type Holocene and Pleistocene. Holocene or Pleistocene. So in our country, maybe Holocene. So it's 1, and put it 1. Okay, Holocene. And recent one. Okay, not it's the previous one. Holocene soil. So it is use F1 is 1, and then F1 is 1, and then F2 will get from this soil type. Then say you have silt, use this 1.09. Okay, also silt. Okay, clay 1, fine sand or silt, then medium sand, and clay sand. Okay, gravelly sand you don't have. The dense sand, the dense sand. What you will use? Dense sand. Okay, dense sand means medium sand. This medium means medium stiff. Medium. Medium. Okay, diameter like this, not medium stiff. Okay, for dense sand you what? Dense sand and SM. Say SM. For SM or in our country, all you use 1.09. Okay, in our country, I mean reverse sand. I mean, if FM is less than 1, so you use fine sand, 1.09. All type of sand, whether it is medium sand, whether it is dense sand. And this medium in terms of diameter of the grain. Okay. So in our country, our sand is fine sand. So all sand will be also silt will be in 1.09. Okay. So it will be in your first, I mean, first, maybe second assignment. Okay. Okay. So fine content, we can get it from here. Okay, liquid limit and plasticity index. So is the fine content, So 50%, 30%, final and so on, you can get this type of trend. You don't know. Okay. Then undrained shear strength. See you, if you don't have any graph here, that's why you don't need here, in fact. But say you want to calculate the QU. If you have undrained test, that is UCS test, and then unconfirmed complete strength test, or UU test, that is triaxial test, and unconstrained undrained test. So if it is that, if you have this type of parameters, I mean this QU or this type of two tests you have, then calculate the QU, I mean CU. We need CU, I mean say bearing capacity, ultimate bearing capacity is equal to what we saw for clay type soil, CU or C, C means CU in fact. C and C we know, C and C. C and C into factor, some factor, into factor, SC, SC and some factors, we know this. And plus, if undrained condition, CU only and then Q naught, Q naught and Q. But here NQ you will see, we will use 1. So CU and C plus Q naught, ultimate bearing capacity. Then other things will not come. So if you have UCS test or unconsidered undrained triaxial test, then we can get directly CU from that equation. Okay, if you have this one, then use QU equal to okay, CU equal to half. You use here half, half QU. Okay. And then a biaxial test, we can get the Poisson's ratio, but we don't have anything. Then shear stress and simple shear test. We don't have anything here. Then we can get tau FMG, shear modulus, very important for earthquake parameters. Okay. Then question angular confliction. Then if we have steady test or if we have a direct shear test, and direct, because CD is very expensive. Direct shear test, you already know how to do it. Direct shear test, then you can get the envelope. From there, you can get CN5. Yeah, CN5. Then oidometer test, I mean concentration test, you will get CC at, as I explained, CS, swelling index and compression index, and over concentration ratio, PC, and so on. PC, PC dash, and so on, or sigma C, whatever you say. If it is sigma, then sigma C, and then if it is P, then PC. Okay. Then compression index also we can get if we have liquid limit, then use this equation. Okay. And then Nishida, this by I forgot, I don't know who proposed it. And Nishida proposed this one in terms of word ratio. In fact, sometimes for calculating E naught, we use this equation for clay type soil. This equation, because in many cases we don't have E naught. Okay. Then and CC can be used, can be calculated from this equation. Okay. So use this equation and get this E naught. Then we have liquid limit and this is a word ratio. Okay, so Q and K, horizontal soil modulus, we can get it. Okay, there is one relation of QU, QU, that is unconventional compressive strength. Okay, it's 25, then it is K is 250. There's relations are there. Okay, so these are the the things that we need to know. Now, what you have to submit? Okay, the first report, what you have to submit? Okay. Okay, first one, assignment 2 maybe, I don't know. Oh, so one by one. Say this is depth. Depth. Say, I mean, you divided some part. Okay, you divided this part in some layers, the 10 layers, 5 layers, or whatever, depending on your soil test. If it is more than 50, then there will be one layer here, say, SPTN value for the 50. So depth in meter. There are two, soil test report that was converted into, and that was in feet. So please convert it into meter by considering 5 feet equal to 1.5 meter. Okay, consider this. Okay, those who have only soil report, they have in feet, unit in feet, depth is given. So though it is given the feet, then you have to write it as meter. So meter. So 5 feet, consider 5 feet equal to 1.5 meter. Okay. Then SPTN value. And you consider this is N60. Okay, N60. Say your SPTN value here is 5. The SPTN value here is say 12. The SPTN value here is say 25. The SPTN value here is 50, all average 50. Okay. The depth, the center. At the center, the depth is say here is 3 meter. 3 meter. Okay. Say this is 10 meter. Center depth. Center means say this is second layer, so this center from the top. Okay. Say this is say 20 meter. Say This is another 30 meter. I mean, 30, say 30 meter. After 30 meter is 50. Okay. Now this is SPD. Then soil type, right? Soil type. Write it here. Say CL. Say ML. Say SM. Say SM. I don't know. Depending on your, I mean, soil type. That in I mean borehole one, that is group one. They have many layers. I think more than 10 or 8 layers. Huh? If I mean you have that, you have to, I mean, use this one also. Okay, not 4 layers only. In someone maybe you have only 3 layers, different soil. Now next, calculate gamma, not calculate, use it, gamma dash in kilonewton per meter cube. Okay, I mean use 8.0 everybody. Okay, because it is not given in your report. Use it because we know, say if it is 17.81, gamma saturated, because we are considering water table at the top, na? We are considering water table at the top. So if it is gamma saturated, gamma sat equal to 17.81. So gamma dash will be gamma sat minus 9.81. It will be almost 8. So there is some justification of this 8. It is almost range is 7 to 8. So use 8 for all. Okay. Then calculate sigma 0. Oh no, sigma 0 dash. আচ্ছা এটা আমি মুছে দিই, মুছলে ভালো হবে। Okay. So it is sigma 0 dash. Okay, dash. What's the unit? KPA. Okay. So as it is 3.0, so it will be 24, na? Depth into gamma dash. So it will be depth 10 is 8. So it is how much? 80. Okay. So it is depth is how much? It is 20, na? 20 depth and 8. It is how much? 28, 160, 160. The 30 into 8, 240 APA. So you got this one. This is a basic thing. Now, as you don't have D, I mean D, sorry, D50, you cannot calculate. You cannot calculate DR. So forget it. No need. Okay. Now calculate C, KPA, pi, depending on the soil, in degree. Okay. So C, so it is CL. As I said, in CL, what you have to use? I mean low plasticity clay. Low plasticity clay, Sauer's equation. So use that equation. Use that equation. That is, I can see our previous. Oh no, here. It is here. So it is somewhere here. Sauer's equation for clay CL. It is 0.38, 0.038 N into 95.76. Okay. Come here. So C will be 0.038. 38 into N is here 5 into 95 point, কত না? 76, না? ভুলে গেছি। So this is the values, এত KPA, this KPA. Okay, put it here. Understood? Okay. So how about the phi value? Say this is undrained consider undrained condition. So 5, 0. In fact, if it is drained condition, there is 5. So in your case, always what you do, you calculate, you consider this is undrained condition if it is clay type soil. Okay, undrained conditions means water cannot, move. Okay, go out from here. If there is any earthquake, even whatever it is, or any, foundation, water cannot go out from there. So 0. And then there is value here, the ml. So for ml, what you do, sorry, what you do, you calculate, sorry, same equation you use, as I said. Oh, no, no, not same equation. For ml, you can use like this. See, you use 15 kPa. Okay, 15 kPa for all, whatever the n value. Okay, so not depending on this n value, SPD n value, just use 15.0 for all groups. Okay, and then this one, SPD n value. SPD n value, as I said, use that equation. That is equation, which one? That one? That is the equation, which one? This one, Peck-Hansen equation, but all keep this 0.37 plus 27.1. Okay, 27.1 minus this equation 0.0004 54 n square. Okay, so use that equation, and for silty soil, ml, for silty soil, whatever you get pi value from that equation, just subtract minus 5. Okay, okay, minus 5. If it is more than 35, sorry, it is more than 35, first convert it into, 35, convert into 35 as I said, and then let us subtract 5 minus 5 degrees. Okay, this value. Okay, then SM. So SM always consider here 0, here consider 0, and then here the same equation, maximum 35 degree. Same equation, maximum 35. Okay, maybe it is, if it is 50, it will be always 35. Okay, always 35 degree. It is 50, 35 degree, less than 35. So you have got these two important parameters. One is the C pi. Then coming to E S kilopascal. Kilopascal. So ES, what we use, as I explained before, use this. For clay type soil, use 3 equations. This is soft clay, then medium stiff clay. Soft clay is less than aspirian value. As I said, I'll give you later on, or you can write here. Soft clay, okay, 1 to 3, aspirian value. Then 4 to 10, 4 to 10, then 8, 8, 4 to 8. 4 to 8 is medium stiff. And okay, 10 medium stiff. 4 to 10, aspirian value. 4 to 10, and then SPT and value 11 to medium stiff to stiff, medium stiff. Then it is up to 15. So if it is more than 16 to whatever it is, it is N. This is N. This is medium stiff. Okay. Then this is stiff, and then this is very stiff. If it is more than 15, and value more than 15. N value more than 15, very, very stiff. Okay. So use this. So this is at 800 TSF. Again, 1 TSF equal to what? If 95.76. So 95.76, yes. Come to the place here. Again, it is plate of soil 5. I don't know what it is there. Maybe medium stiff is written. It's written medium stiff. Okay. So if it is medium stiff, so what we have to use? Medium stiff soil, you have to use 350, up to stiff soil, 350. So it will be 350 into N, N means this 5 into 95.76. Okay. Similarly, here ml, that is, we will use the sandy soil one, sandy soil SPD N value is given here. So N value, this one, sandy, silty sand, we will use this silty sand, 300 into this. So you have to calculate CN, oh, CN. CN is required, CN. So what? So before that you have another column. Say I am writing here, CN. Calculate CN. So it is in between 5 and ES. Okay, the CN you will get. Okay, CN you will get because sigma 0 is given. So CN you can easily get. SPD is given and SPD and 60. N60 is given. So and you calculate the N1. Oh, N160. Yes. Then N160, calculate N160. Okay. I mean, using CN, you can get N160. Okay. These two columns will be inside this one. Two columns. So N160 will get it. So N160, then first calculate CN, then N160. And using this N160, then you can get the ES. ES of silt, ES of sand, ES of sand. Okay. I mean, here, this is, you'll get it. So this is one table. Another one, as we don't have space here. Next, continue. Just continue that one. So now you got it, yes. Yes, you got the yes. Now, NH. NH, calculate NH. Okay. For clay type soil, you don't need this NH. NH, no need. As it was clay, it was Cl, it was Ml, then it was Sm, it was Sm. Sm. Okay. So Cl, for Cl, N is not required. So then K, subgrade modulus, K. So directly we get these values. From which one? From these equations. Yes, etc. These equations. Then subgrade reactions for quasi soil. Basics equation. Directly use this equation, short form. Because this D, diameter of the pile, you don't know. The E and IP, you don't know, is not given. Direct use ES divided by, oh, Poisson's ratio you need to calculate again. So I forgot to say. So ES divided by 1 by Poisson's ratio square. You say you need again Poisson's ratio. Poisson. So it will be Poisson's ratio just after ES. Poisson's ratio. Use here. So for Cl, what you have to use? 0.40. For ml, it is 0.30. For Sm, what you have to use? 0.25. This is 0.25. So it will be easy for your task, as I have given the values all. So you know Poisson's ratio of this one, you know ES. So you can get this value, that is, this value K for clay type soil is equal to Poisson's ratio divided by 1 minus ES divided by Poisson's ratio square. So this value, you know, this you can get. You can get. For ml, you have to use that, I mean, chart. Okay, this one, ml also. This submerged condition, submerged condition. So submerged condition, if you have now say 4 to 10, so submerged is 200 to 100, 1000, 1400, then 1400 to 500, and so on. So come here. Now it was 5, then as 3, 10, 20, and 30. Sorry, n value 5, 12, 15, 10. Okay. So according to that one, you will get these values. Submerged one, submerged from the table. So ML, SM, you will use the same table. Okay. Okay, this NH. Then K will be NH into a depth ছিল কত? এটা depth ছিল হচ্ছে তোমার 8 মিটার না নাকি 10 মিটার? I forgot. So the depth that it was 8 meter, whatever it is, 15 meter, multiply 15 means it means depth means at the center of that one. Okay, depth ছিল কত? এটা first একটা 10 meter. Oh, 10, then 20. Then it is 10. Mm-hmm. Razor. Oh no, eraser. This is razor. Okay. So it is 10 meter. It is 10, it is 20, NH into 30. Okay, this is the highest one. Highest one, the value is more than 50. So it is a very, so it is 12,000, 12,000. So it is 12,000. And other one you have to calculate by interpolation. So 12,000 into 3 into 30, 36, 0, 0, 0, 0. It is 0. So this is your K. Okay. This is your K. Hello, Assalamualaikum. Hello, sir. Take us. Okay. Take us. Okay, sir. Okay. Assalamualaikum. Sorry. So Patwari called me. Professor Patwari called me. Okay. So here Poisson's ratio. So Poisson's ratio you get. Sorry, not Poisson. K. K. So you got it. So any more things? Okay. VS. VS. Use the equations that I already showed. So VS, that is shear velocity in what's that here? Shear velocity, this one, VS. Okay, meter per second. So this shear velocity, using this equation, you just put the values and VS and then G max, because G max is required. We have this VS then G max. Okay, using that equation. Okay, rho V Z square. So what is the rho? What is rho that you will use? That's the point, Rho কোনটা হবে বলো? Rho, as you know, gamma, gamma dash. ঠিক আছে? So gamma dash, you know, 8. You consider this 8. So add 8 point, sorry, 9.81. 9.81. So it is 17.81. Gamma equal to 17.81 kilonewton per meter cube. But you need rho. So if you divide it by 9.81, this is rho z, তাই তো? Rho z, so you will get rho. Okay, so it is around okay, like 2, somewhere it is 1.8 and so on, and or 1.9. But here it will fix. এটা ফিক্স আছে না? ফিক্স সবার জন্য একই 9.8 যখন ভাগ করে দিবা তাহলে এখানে রো পেয়ে যাচ্ছে না? রো ফার্স্ট ক্যালকুলেট রো তো এখানে চলে আসবে না, সামার হিয়ার, হ্যাঁ, রো, রো, দেন ফাইনালি gmax. Anything I kept? No. Okay. Okay, you don't have, we don't have anything. Okay, DR because you don't have that. Okay. So these are the parameters that you have to submit. Report according to your soil test report. Maybe next week. I don't know when can it will be, but I will talk to Umama to fix it. Whether you submitted the previous one. এক নম্বরের এটা দিচ্ছ তোমরা নাকি এখন অ্যাসাইনমেন্ট দেওয়া হয় নাই? তো এক নম্বর অ্যাসাইনমেন্ট তো আমার মনে হয় দেওয়া হওয়ার কথা, আমি জানি না, দেয় নাই, হয়তো
স্যার
ভুলে গেছে।
দেওয়া হয় নাই এখন।
আল্লাহ, এটা তো দিয়ে দেওয়ার কথা। প্রথমটা পরপরই একই জিনিস, তো প্রথমটা তো আগেরটার উপরে। ঠিক আছে, এটা সেকেন্ড রিপোর্ট কিন্তু, তাহলে তোমাদের তো একসাথে জমা দিতে হবে। ওকে, দ্যাটস অল ফর টুডে, সো ইউ ক্যান গিভ ইউর অ্যাটেন্ডেন্স। ওকে, সেন্ড ইউর আইডি নাম্বার। It is recording, so I can get it from the recorded file. Sakin, Anika, Shahin, then Mutasim, 5, Jubair, Papi, 42, 142, Asmain, Mahatab, Papa, 234. So those who gave your attendance, you can leave. So maybe today you will get the notice from Umama sir, Abu Umama sir, then we will announce the deadline of these two reports. One is the top, I mean, number one. Number two, just that I gave you now, use that, because it is, I will give you also this file, I mean, the recorded file to you. It's already 84, Mahir, Nafis, 86. Okay, no more, eh? If not, then we can leave. So today 86 present only out of 118. So your attendance will be very low. Okay. See you next week, the same time, 11:45. Hasina মাত্র দিল। Anybody left? আবির, নিলয় মাত্র আসলো। কোথায় ছিল ওরা? 90 হয়ে গেছে। Anyone left?
রেকর্ডিংটা স্যার দিয়ে দিলে একটু ভালো হইতো।
রেকর্ডিংটা আগেরটা দেই নাই না, আগেরটা লাগবে?
স্যার মানে সবগুলা দিয়ে দিলে ভালো হইতো স্যার, ওই যে অ্যাসাইনমেন্ট করার সময়।
আগেরটা রেকর্ডিং দেই নাই আমি না।
স্যার
তোমাদের এফওটিপিতে কোনটা শেয়ার করছি? তোমাদের এই যে ইয়েটা নাকি শুধুমাত্র
স্যার
ফাইলগুলো?
লেকচার 1 সাইট ইনভেস্টিগেশন ওইটা দিয়েছেন স্যার।
আচ্ছা, বুঝেছি, তাহলে শুধুমাত্র রেকর্ডিংটা দেওয়া হয়নি না।
জি স্যার।
রেকর্ডিংটা দিয়ে দিব তাহলে, হ্যাঁ।
স্যার আজকেরটা স্যার একটু দিয়ে দিন কষ্ট করে স্যার।
আচ্ছা আচ্ছা আচ্ছা, দিয়ে দিব। ওকে 94 প্রেজেন্ট হয়েছে আলটিমেটলি। আর তো আমি অ্যাকসেপ্ট করবো না। নো মোর। থ্যাংক ইউ। হ্যাঁ, ওকে বাই।